All right, so I want to preface everything by saying that this was supposed to be Bilge's talk. Unfortunately, not everyone has the best of luck with visas, so I'm here presenting her work. This is all her doing, so let's see how it goes. All right, so today I'm going to be talking about hybrid search. Specifically, I'm going to talk about how we implemented hybrid search for our tutorial search for Haystack, and we actually used Haystack to build hybrid search alongside OpenSearch as well. So I'll show you how we've done that. So first of all, I'm going to look into retrieval applications for search because a lot of what we're doing is retrieval technology, and then I'll look at keyword-based versus semantic search, and then we'll look into how we build hybrid search with Haystack. All right, so I'm going to start off very, very, very simple. And let's assume we have a database full of documents. That could be an OpenSearch database, or we simply might even have the World Wide Web. We want to search through an API like Slack or GitHub or your emails. And we might want to perform search for multiple reasons. It might be that we want to find the correct document in a vast majority of documents. Or it might be because we want to start off an question answering system, which might be extractive question answering, or it might even be generative question answering. But everything really starts with search. And often this search is described as retrieval. We do retrieval because this is how I sort of like to depict it. If we have a majority of our documents in a database, we've got thousands of them, we don't necessarily want to have maybe a language model, whether it's extractive or generative, have to look through absolutely everything. So we have this layer of filtering where we can narrow down the number of documents. That means we're gaining inference time. And it also means, and I'm going to very briefly talk about this, although it's not going to be within the application I'm building, it also means that we're able to give the most relevant information to a large language model so that it can answer the queries, but we don't have to necessarily retrain it. And most modern LLM applications these days look a bit like this. You have a database somewhere, you have your documents, you have a query, and you have this retriever component, exactly like acting like this filter, followed by a generative component. And then you've got an answer, hopefully. So I want to depict that in a very simple way. So this is me asking ChatGPT, what time is the talk about keyword and semantic search? And if I'm lucky and I'm using a good performant large language model, I may be getting an answer a bit like this that's telling me, I'm sorry, I don't know. But what we try to do with search or retrieval is actually this. So I've changed my question to this large language model. And it's not just a question, it's actually an instruction. I've said, answer the query based on the provided context. And then I've given it some context. And then I followed it up by the same exact query. Now, how do I even get here? This step is not that simple. And this is where we start talking about search. And this is where we start talking about what is the best way for me to give this context to a large language model, an extractive model, whatever that might be. How can I actually get that out of my database into a format that a language model can actually work with? And here I've cheated. Obviously, I've just gone and copy-pasted what you had on the OpenSearch page. But we're going to have a look at what we can do, what kind of systems we can build to make this happen in an application. So what kind of search we use often boils down to two questions. It can actually boil down to many questions, but the two simplest questions you kind of have to answer is, what kind of data do I even have? And are there models out there? So if I'm going to be doing semantic search, are there models out there that actually is going to understand my data? But actually for us, when we were looking into tutorial search, what really became the main question to answer was, what kind of queries am I even expecting people to ask? Because if I'm expecting people to ask full-formed questions all the time, then I might want to completely rely on semantic search. If I'm expecting them to just go in and write a few keywords, then maybe I can completely rely on keyword search. So quickly about keyword versus semantic search. This is actually from the OpenSearch documentation. And and we've got the query Wild West. And the two things do slightly different things. You can see what keyword search produced as a result on the left-hand side, and you can see what semantic search produced on the right-hand side. On the left-hand side, wild and west, they're keywords, and we're just looking for them in a pot of words all jumbled up together, and I'm getting results for wild and I'm getting results for west. Whereas on the semantic search side, I'm actually semantically understanding what I mean by wild west, and I'm getting probably results that are a bit more effective for the query Wild West. So keyword search, two of the most common algorithms out there is probably TF-IDF and BM25, and these approaches look at a set of words and they approach them as a bag of words. So it doesn't really matter what order these words come in. It says here exact match. I put them in quotations because that's not entirely true these days, because we do have keyword-based search algorithms that are really good with synonyms, for example. But at the end of the day, it's close to being an exact match. Whereas semantic search approach things very differently. We get a sentence, a word, a paragraph, whatever that might be, and we vectorize them. And then we actually compare these vectors to each other, which results in a sort of vector space like this, where I could potentially compare the words coffee and tea and say, okay, they're close to each other in the vector space, whereas ship is maybe far away. So quickly about Haystack, and you'll soon understand why we used Haystack and OpenSearch together to build document search, hybrid document search for Haystack. Haystack is our open source LLM framework. It's all written in Python. That QR code should take you to our GitHub page. And it's really built on the concept of two main pipeline types and document stores. So a document store could be OpenSearch. It could be Pinecone, Weave, Milvus. For us, we used OpenSearch to build our tutorial search. And an indexing pipeline in Haystack allows for you to pre-process, chunk, prepare, get anything done to your documents, whether they're PDFs, Markdown, TXT, to be in a format that's the language model of your choice when it comes to your query pipeline can actually use. Again, it's just a framework. We're providing this framework to developers to build out their own NLP applications. This graph you're seeing here is a classic pipeline and a classic query pipeline that we would build to build a retrieval augmented generative pipeline, where we have a retriever followed by something like a prompt node. But again, we're providing the framework. A developer that wants to build with Haystack can mix and match each of these components, and you may end up with a pipeline that does extractive QA, for example. And again, we provide the option for you to choose what model is used at what stage. So you might say for the retrieval part, for semantic similarity, I want to use an open source model off of Hugging Face. But for the generative part, I want to use an OpenAI model or a model deployed in SageMaker. Another option is, but I'm not going to be getting into this today, but just to give you an idea, you might skip the whole indexing part or curating your database and actually say, oh, I'm just going to connect to whatever information I'm consuming through an API. So obviously, there's a lot to learn to build with Haystack. So we do have a lot of tutorials. Anything from the simplest extractive question answering tutorial to a more complex retrieval augmented generative tutorial. And we wanted to build some sort of search. We're getting more and more tutorials on that page, and it's getting really hard for people to find the right tutorial that they need to get to what they want to do. So we wanted to provide some sort of search, and we experimented with 3 types of search. Number 1 was simply semantic search. Number 2 was keyword-based search, and number 3 was hybrid search. And when we did keyword search, so just a quick bit of information, we are building all of these pipelines with Haystack, but we're lucky enough that our company also has a commercial product called DeepSet Cloud, which means that we don't have to worry about the deployment, the testing, the exposing the API to end users for A/B testing and evaluating, etc. So we were able to also build this with DeepSet Cloud. And the first thing we tried was keyword-based search. And this is an example where we are creating an agent with memory. We do have a tutorial on this, but keyword-based search returned absolutely nothing. It was looking for exact word matches, and it was looking for exact word matches of each word being contained in the tutorial. Unfortunately, we did not have that, and it didn't result in a good search. When we did semantic search, though, we did get some relevant results. Now, another query we tried was retrieval augmentation. And this was interesting because actually here, keyword-based search provided a lot more relevant results than semantic search. And the reason for that is the embedding model we were using didn't necessarily have the context to know what we meant by retrieval augmentation. So it was returning to us results that did contain retrieval and augmentation, but not exactly what the context we were looking for. And this is a good example of keyword-based search actually sometimes being a lot better when your query is slightly out of domain for the embedding model that you're deciding to use. So I have two options. I can either train my own embedding model, that's a possibility, but the route we decided to take was to do hybrid search, because the more and more we did these types of experimentations, the more and more we were able to see that both search algorithms had their own advantages for us. So we have two types of retrievers we're going to use. One is going to be the BM25 retriever. If I use a BM25 retriever, we often do precede that with a ranker as well. And I'm going to use what we call an embedding retriever. And at the end of the day, I want to get to something like this: customize prompt node. I'm going to come back to this query because this ended up being kind of a special query, because prompt node was actually is one component in Haystack. And we wanted to make sure that when someone wrote prompt node, we were getting the prompt node, not a document that mentioned prompt and node completely irrelevant to each other. But customizing prompt node is also quite a good semantic search candidate as well. So first of all, we built an indexing pipeline. All of our tutorials are actually Python notebooks. It's all stored in a GitHub repository. And we have a GitHub action that every time we change a Python notebook, it's converted into a Markdown file. And we can then call the endpoint in our DeepSet Cloud indexing pipeline saying there's a new Markdown file. And it goes through a Markdown converter. And then that gets pre-processed. It gets chunked up into smaller segments. Our tutorials can be quite long. And then we use the same model we're going to use for the embedding retriever to then create embedding representations, and then we index them into an OpenSearch document store. So that looks a bit like this in Haystack. The first thing we have is our OpenSearch document store. The second thing we have is a Markdown converter, and we are extracting headlines. We're making sure that each section of the tutorial is also included. We have a preprocessor. Again, this was a lot of trial and error as well. Exactly how to split the documents, how many words to split them by, etc. And then we have an embedding retriever. Here you see that we've decided to use a sentence transformer model. So this is being pulled straight from Hugging Face. And you can see that the retriever has top K5. This means if I were to use this retriever in an indexing pipeline, by default, it would then return, when we do use the retriever, it would return the top 5 most relevant documents. Now I've got the components, and like I said, Haystack is built on the idea of pipelines. So here I'm going to be building an indexing pipeline, and that's simply a matter of adding nodes to a pipeline and then telling each node what its input is. So file and query are special input types because they sort of indicate the first entry point to a type of pipeline. So if it's a file type input, then we know that we're probably going to be starting an indexing pipeline. And here, that's what we're doing. So we're telling the pipeline that when you get a file, the first thing you have to do is go through the converter. So this is going through my Markdown converter. Then it's going through the preprocessor. The output of that, now the preprocessed converted file, I'm going to feed it through the retriever. The reason I'm doing that is the retriever is where I know what embedding model I want to use. So I'm creating embedding representations for each of my documents. And then I am writing those to OpenSearch. So here you see an example of me running this pipeline on tutorial 1 and tutorial 2, for example. All right, now for the next step. We want to do some sort of search on this. As you saw, keyword search, good for some cases. Semantic search, good for other cases. So our final experiment, which actually did end up going into production, was hybrid search. This is where we have our document store, and when a query is asked, both embedding retriever and keyword retriever is operating on the whole data set at once. And then we want to have some way to join those documents. And then in some cases, we also use a ranker at the end of this. And then I want that to be the final returned set of documents that hopefully is going to be the most relevant to the query the user asked. And we have a few options of how we join these documents. We can simply concatenate them. We can use reciprocal rank fusion. So this is a good technique so that we know that if the same document, for example, is returned by both retrievers, we're going to rank it a lot higher than the others. Or we could just use a function called merge. Merge is sort of unique because merge function also has the capability of you defining a weight to one retriever or the other. So in some cases, you can give more weight to anything returned from, for example, keyword-based search versus semantic search or vice versa. And we actually went with concatenation. Again, this was based on a lot of experimentation, trial and error. But at the end of the day, we found that if we were to concatenate and approach all of our documents the same way, we were getting better results than we would by giving precedence to one retriever or the other. All right, so how does that look like? This time we're going to be creating a query pipeline that is just simply going to be doing document search. The first thing I'm doing is declaring my keyword or sparse retriever. So in this case, we're using BM25 retriever. And you'll notice here I have custom query. And this is very unique. The way we've built this custom query is very unique to the fact that we're using OpenSearch. And I'll go into why exactly the custom query is as you see there in a bit. Next, I am also defining a dense retriever or a semantic-based retriever. And here I'm using the same model I used before. It's being pulled in from Hugging Face. And then I am saying join documents. I've got a join document node. I'm also using a ranker. So this is going to then, based on all of the documents retrieved by both the keyword and semantic-based search, it's going to re-rank them into an order that might make a bit more sense. And again, I build my pipeline. This time, you'll notice that the query, one of those special input types, isn't going into just one node, it's going into two nodes. It's going into both my sparse and my dense retriever. And then I'm joining the documents returned by both of those nodes. And then I'm doing some re-ranking. Now I can run this pipeline with a query, and hopefully I'm getting some relevant results. So there was a custom query there. And this is where we can define to the OpenSearch BM25 retriever exactly where we want it to do search on. So in our context, for example, we told it to only focus on the content field. And we set fuzziness to auto. Fuzziness is where we can sort of define how much leeway we're going to give to the user making, for example, a set of typos. And then we use the operator and. And the operator and actually came because of a lot of our component naming. We could have also gone with operator or, but for example, here you can see pipeline with prompt node. And again, this was a situation where, like before, when I said customizing the prompt node was a special query, we did not want to have a result that returned prompt and node completely irrelevant to each other, but prompt node being together was going to be quite important. And if I had the AND operator, this is what I was getting back. But thankfully, we also had semantic search. So even though just keyword-based search wasn't returning us the perfect answer, we were getting some relevant answers from semantic search. So once we joined those documents and had a whole basket of documents that we could query on, we were still getting the relevant documents out. And with that, I want to end by showing you this article we wrote with actually David. This is an article where you can see the whole architecture of us building both an indexing pipeline and a query pipeline with OpenSearch and Haystack. But in this case, we're not using a model from Hugging Face. We are actually deploying quite a large model on SageMaker, and we're making use of that. And we're indexing documents from the OpenSearch documentation so that you can have a generative documentation search on OpenSearch documentation. And with that, I want to end with these two resources. The first one is the Haystack tutorials, and the second one is a GitHub discussion on the Haystack 2.0 major release. Because we've noticed that although Haystack is very flexible already, we want to make it even more transparent to engineers about how they're building applications that make use of large language models, especially when it comes to what we were just talking about today. So everything I've shown so far, the documentation search, the retrieval, etc. For the tutorial search, it ended there. We were looking for documents, we were looking for some sort of relevant content, and once we got that, we were done, and we wanted to return the tutorial itself to the user. However, it turns out how you do that search and how you do that retrieval is also very, very, very relevant to how you want to do generative QA, for example, on documentation. At the end of the day, a lot of these large language models, although they're great, they don't necessarily know the entire world, and especially not your own data. So if you want to build a system that starts with this kind of search, and based on that, we're doing some question answering with a large language model, whether that content or context is actually accurate and what the user is intending to see makes a big difference in the results you're getting back from a large language model. And that's it. Thank you very much.